This is question 8 off the paper review for Canvas test number 3. And it says the directions say to solve the triangle. And I'm just going to draw this out really quick. And again, this triangle is not to scale. But what we have here is we have angle A, C, and B. And side A, side B, side C. Okay, so angle B is 50 degrees. Side A is given as 3. Side B, I don't know. And side C is 6. Okay, so first of all, I got to find out what I'm given. And it looks like I have side, angle, side is the case. So this is Sassy Snake. Okay, and Sassy Snake is a way to remember if you have an SAS or an SSS, because that's the sound snake makes, we know we have to use law of cosines. Okay. All right, so I have to use law of cosine to figure this out. All right, so there's several, and I believe this is on your formula sheet, so I'm just checking really quick while I'm making this. And yes, it is on here. Remember, I have A and C, and I have angle B. So that'll dictate which one of them do I use. Okay? All right, I'm going to go after side B. So in order to do that, I'm going to use B squared equals A squared plus C squared minus 2AC times cosine of angle B. Okay? So B squared equals, now A is 3 and C is 6 minus 2 times 3 times 6 cosine of angle B, which is 50 degrees. Now I'm going to rewrite this. 3 squared is 9. 6 squared is 36. 2 and 3 is 6. 6 and 6 is 36. Okay, do not subtract 36 from 36, okay? Because that second 36 is with cosine of 50 degrees. But I can add these two together. So I get 45 minus 36 cosine of 50 degrees. Okay, I'm getting there. So in my calculator, I got to be careful. I'm going to do 45 minus, and then I'm going to use parentheses and put 36 times cosine of 50 degrees. And when I do that, I get B squared equals 21.86, and I'm going to take the square root of that. And when I do that, I get B equals 4.67. And it's 675, so 4.68 for side B. Okay, so now that I have side B done, to find angles A and C, I have to use law of sines to do that, or law of cosines, excuse me. Do not use law of sines. Whatever you start with, you finish with, okay? So I'm going to go after angle C. Okay, so now I have to use C squared equals A squared plus B squared minus 2AB times cosine of angle C. Okay, so C squared. C squared is 6 squared. A squared is 3 squared. B squared is 4.68 squared minus 2 times 3 times 4.68 times cosine of angle C. Okay, so let's make this look a little bit better. So 36 equals 9 plus, now 4.68. That gives me 21.9024. And then let's do this. 2 times 3 times 4.68. And when I do that, I get minus 28.08 times cosine of angle C. I'm going to add these two together. So 9 plus 21.9024. Okay. And I get 30.9024 minus 28.08 cosine of angle C equals 36. I'm going to move the 30.9024 over the other side. And when I do that, I get positive 5.0976, and that equals negative 28.08 cosine of angle C. Now I'm going to take that 5.097 and divide it by negative 28.08. And when I do that, I get negative 0.1815384615 equals cosine of angle C. Now to get angle C by itself, I'm going to take the inverse cosine of both sides. To get inverse cosine of negative 0.1815384615, and that'll give me angle C. So on my calculator, I'm going to do inverse cosine, and then I'm going to hit the answer key, which should have that answer of negative 0.181, etc. And when I do that, I get angle C equals 100.46. I just rounded to 2 decimal places. Okay? So I have angle C. I have side B. Now I need angle A. Now angle A I can find by taking 180 minus angle B minus angle C. So 180 minus angle B, if we look back up there, was 50 degrees. Minus angle C, which I just found to be 100.46, will give me angle A. Okay, so 180 minus 50 minus 100.46. And when I do that, I get 29.54 degrees. Okay, all right, so that is number 8. I used a lot of cosines on that. And again, the formula is going to be on your sheet, so you will be able to look at that. I'm just trying to see what the next question is. Okay. All right, guys, you know what? I'm just going to end the video because I don't want to take up too much time, and I'll start with question number 9 starting the next video.